Look at the sheer variety of ammunition feeding systems in modern firearms. We use boxes, drums, and belts, all alongside tubular magazines, clips, and cylinders. If the goal is simply to load a weapon, you'd think engineers would have settled on one universal, flawless design decades ago. But perfection is a myth, and every design is born from desperation. Early infantry combat was governed by a brutal, simple rule: the soldier who shoots the fastest lives. Firing an early matchlock weapon was a grueling process, requiring 40 distinct steps to pour powder, pack the ball, and manage a burning cord. The flintlock mechanism improved ignition speed by replacing the burning cord with a spark, but the architecture of the weapon retained a fatal bottleneck. Every single shot had to be manually loaded from the muzzle. Surviving the next era of warfare meant bypassing the muzzle entirely. Gunsmiths needed to engineer a way to store multiple live, explosive rounds safely inside the body of the weapon itself. The transition to multi-shot systems changed the terms of an engagement. Survival no longer depended on the steady hand required for a single perfect shot. It became a question of how much lead an army could sustain in the air at once. The first viable solution to store those extra rounds was the tubular magazine. By housing cartridges in a long pipe directly beneath the barrel, the rounds are stacked end to end, keeping the weapon remarkably slim and easy to handle in heavy brush or tight trenches. This architecture works perfectly, right up until the military demands longer range. Long-range ballistics require aerodynamic, pointed bullets. But inside a tube, the sharp tip of one bullet rests directly against the sensitive, explosive primer of the round placed right in front of it. When the gun fires, the violent rearward force of recoil jolts the entire stack of ammunition. Those pointed tips slam into the primers ahead of them, triggering a catastrophic chain detonation straight down the tube. To prevent the rifle from detonating in the user's hands, engineers had to make an immediate compromise. Tubular magazines forced the shooter to rely strictly on blunt, flat-nosed bullets or shotgun shells. Solving the capacity problem created a severe aerodynamic constraint. Gunsmiths actively crippled the weapon's long-range ballistic performance just to keep the internal magazine from exploding. Modern infantry required those aerodynamic pointed bullets to engage targets across vast battlefields, completely disqualifying the tubular magazine for standard rifles. The solution was the box magazine. It safely accommodates pointed rounds by stacking them vertically on top of a compressed spring, eliminating tip-to-primer contact entirely. But look closely at military hardware across the globe, and you'll notice a distinct visual anomaly. Some modern box magazines drop perfectly straight down, while others possess a heavy, sweeping curve. This is dictated by cartridge taper. Certain ammunition requires a sloped, conical casing to extract reliably from a hot chamber. When you stack these heavily tapered cartridges on top of one another, they naturally fan out. To maintain a functional feed angle at the top, the magazine housing has to arc. Cartridges with straight or minimally tapered casings don't fan out the same way, allowing their magazines to remain shorter and perfectly straight. A box magazine silhouette is never an aesthetic design choice. The steel and polymer are structural hostages, forced to conform to the exact geometry of the bullet they carry. The box magazine has a hard limit. Go much past 30 rounds, and the magazine becomes too long for a soldier to comfortably shoot close to the ground. Yet military doctrine still demanded extreme, continuous firepower. The drum magazine addresses this by coiling cartridges in a flat spiral. Using a heavy torsion spring, it squeezes 70 or more rounds into a relatively compact circular footprint. The cost of that capacity is severe. A fully loaded drum introduces massive dead weight to the front of the weapon. Worse, the complex internal moving parts drastically increase the likelihood of a jam in the middle of a firefight. For sustained suppressive fire, engineers pursued a radical alternative, abandoning the concept of an enclosed magazine entirely in favor of an ammunition belt. Belt-fed systems force the weapon's own mechanical action to actively pull and strip disintegrating metal links. As long as you can link belts together, you have infinite capacity, paid for by the extreme weight of the ammunition and the heavy mechanics required to cycle it. Military doctrine was forced to fork based on these mechanical limits. Squad mobility requires the light, fast reloads of a box magazine, while static area suppression demands the heavy, infinite logistics of a belt. Capacity and rate of fire dominate battlefield design, but in specific environments, absolute fail-safe reliability is the only metric that matters. When tracking dangerous game, a single malfunction is a death sentence. Most modern mass-produced rifles use a push-feed system. The bolt loosely shoves the round out of the magazine and into the chamber, and the extractor only snaps over the cartridge rim at the very last millimeter. The older, more complex alternative is the controlled round feed system, defined by a massive, distinctive claw extractor. This claw violently grips the base of the cartridge before it even leaves the magazine lips. It physically refuses to let go of the round through the entire cycling process, guaranteeing a feed even if the hunter is working the action upside down or in a blind panic. Push feed is mechanically simpler and much cheaper for military mass production. Controlled round feed is an expensive, over-engineered insurance policy demanded by those who cannot afford a single mechanical failure. After examining every major design, a single pattern emerges. There is no such thing as a perfect feeding system. Every gain in capacity or speed is paid for with a loss in mobility or reliability. The mission dictates the compromise. Box magazines feed the highly mobile infantry rifleman. Tubular magazines feed the close-quarter shotgunner. Belts sustain the squad's suppressive fire, and controlled feed actions protect the solitary hunter. Every sweeping curve of polymer, every heavy torsion spring, and every disintegrating metal link is an evolutionary scar born directly from a past engineering failure. But the mechanical spring-loaded magazine may eventually go extinct. Emerging technologies like solid caseless ammunition and electronic ignition systems threaten to bypass these physical bottlenecks. Yet, as long as humans innovate new ways to fight, the mechanical arms race of compromise will continue, constantly trading one lethal flaw for another.